Hi, this is going to be a JavaScript tutorial or example of how to set up a ThreeJS scene using WebGL. ThreeJS is from Mr. Doob, and he is on GitHub and he has his own website for ThreeJS as well. So if you just Google ThreeJS, you will find lots and lots of stuff and many two examples to learn from with full source code. So let's get going. Before I leave this page, you visit the GitHub and download the zip. This is a 161 megabyte file, so it takes a while if you've got a slow connection. I've already downloaded it ready for use. So let's set up our ThreeJS WebGL scene. First off, create our directory structure. Includes CSS if we use CSS, JavaScript, and ThreeJS. It should be mirrored in here now. Need to create a HTML file. Index. Perfect. It's app. And let's get the right folders. Includes JS app. We will need to add ThreeJS before that. Do we need any CSS? New style sheet. Let's just test our page for no errors. App.js. And our app JavaScript file. And now we need to get ThreeJS from our zip file. So open your zip, find the folder it belongs in, and build ThreeJS 3min, almost half a megabyte, and add this to your HTML file. Like so. Refresh the page, no errors, good. Let's begin building. So all three JS scenes, much like Away 3D and Babylon JS, come with a camera, scene, and renderer. Now, I've got to add my onload. That's our lazy man function. Buggy. That's been all good. Perfect. This will help us get scope if we ever lose it. Sometimes might not need it, but let's keep it in just for now. And we don't global scope variables, we're going to keep it all encapsulated inside our application, which is lesson 3.js. We're going to have a light, which is going to be a directional light. And we're going to have a sphere mesh, and we're going to have a sphere material, and we're going to have sphere geometry. They should be in better sequence. You first have to declare the geometry, and then you should declare the material, and then you apply them by creating the parameters of the mesh. But we'll come back to them. Let's get the initialization done first. So first of all, we need to initialize a container to working. So HTML element we could use, we'll just create one, and we'll call it container. Container equals document dot create element div, and it's an ID of sometimes camel case just doesn't feel right. And we append it to our body. Append document.body append, I think it is. Yes. And that should be fine. Check there's no errors. Looks good. So we are going to use the style sheet. I don't want margins or borders or anything like that. So HTML body no scroll bars. Sure, widths and heights 100%. Probably don't need that. But what the hell? That looks correct. Okay, let's set our scene up. Set our renderer. Which is a WebGL renderer. We want anti-aliasing. I'm going to spell this. Anti-alias. True. And the background color for our scene. I like to work on black myself. And we need to append the renderer to our container. So we're rendering WebGL to the container. also need to set the size to render. This is not prepared, so I'm doing this on the fly. So I work it out as we go along. Done it many times before, just it's not something I tend to commit to memory. And that's WebGL blank. Perfect. Looks good. Looks good to me. Now we have cameras. Scene is where we place our objects. Lights, 3D meshes, models, primitives are spheres, cubes, planes, and camera is what we look through. So camera is new THREE.PerspectiveCamera, and let's just go get the API for this. For the parameters, there it is. Field of view, aspect near, far. So field of view 45 will about do, usually does. And aspect is the dimensions of your screen, browser, width by height, and near is how close you can see things, and far is how far away you can see things. So let's 10,000 guess at the moment. And then we want to set a position for our camera in the scene. Which 0, 0, 0 would be dead center, but we want to look at the center of the scene. So X, Y, Z, 100 up, 300 back. That should be cool. Now, we need camera controls. Otherwise the camera is just going to sit there and look in one direction and we've got no mouse control. Luckily this has been built ready for us in something called, let me change the order of this, is it bugging me? Camera controller, and it's I'll tell you now, it's in the examples folder from ThreeJS from GitHub in JavaScript. Controllers, and it's called Orbit. ThreeJS controllers. And so let's include that. I think it's the Orbit controller. What was it? The trackball control? No, I think it's the Orbit controller. So THREE.TrackballControls. Give it the camera. Renderer. DOM element. Let's just refresh that. Make sure it works. I type trackball control. Orbit controls. They take the same parameters, I think. Yeah, they all do. Let's just check that. It does, okay. So that's our camera controller, which will, oh, I have to set a target for the camera controller to look at. X, Y, Z, and I said we want to look at center, which is origin in some cases, or 0, I think ThreeJS calls it, but I like the set. Now, let's add first, there's helpers in ThreeJS which are, well, allow you to see, get your orientation, which way you're facing, which way you're looking, and they could be a godsend when you're developing a 3D application. So what I find, I use two primarily, is the axis helper and the grid helper. For this one example, I'm just going to do the grid helper. I'm never going to reference it again, so I'm just going to make a variable here. I think it's size and gap. I think it's 2 parameters. I'll have to check again. Size and step. So close. 110 sounds good to me. And we add this to our scene. And next we shall, I'm thinking we could render now, or we could build something first. Let's render first, I'm thinking. So this will be, I'm doing this all in the constructor, the base of the app function. I want to put this in init. And function render. Which is the scene in the camera. Let's check it compiles. And we should run init. And there we have our grid helper. As you can see, our controller is not doing anything, so this kind of defeats the purpose of object controls completely, as that would happen. All we've done is set the position. So let's find out what's gone on here. We're missing something. Camera controller. Let's take a look at this one. some ThreeJS, especially example classes, which you will use a lot of these very, very useful stuff. Loaders, object FBX loaders. You won't find any documentation on them, but you will find examples of them, which is good enough if you can read the code. It's not too complicated, so you just run through it. So we have object controls. They've set the camera, they've event listener, and dampening. Yes, that's dampening is inertia, smoothing, and let's bring that to ours. But I'll leave it off for now, and we'll come back and turn it on. So we want controls. Controls that updates one line. And if we go back to ours, controls is not defined. Camera controller. I think we need mouse event. Add event, mouse down. Resize. Ah, right, that's request animation frame. We didn't loop, we're only doing render once. And there we go. So left mouse button down and drag. Very, very basic scene. As you can see, it's very jumpy, it's stuttery, it also moves insanely fast. You'll find a much smoother camera controllers is the trackball, but you lose the orientation. So if I was to drag on this side, it would twist and you'd lose the flat level of the perspective. So the trackball controller is not the best to have. And if we enable dampening, you've got slight inertia, but as you can see, it speeds up again, which is insane. And you have to play around with these settings, which I have for quite some time. You get dampening factor, and I think it's speed, rotate speed. There's something silly like 0.07 for each of them, something like that. Yeah, that's better. Still way too fast. Let's try swapping these. So that's a bit smooth. That's still way too fast. But it does add an inertia. It's not the best camera controller. You can write your own, but it works. So we've got the camera, we've got rendering, we've got a helper, and we've got a camera controller. Now let's build a scene. Part of the scene, we'll put it in there. And we need a light, which is a THREE.directional light. And directional lights are parameters, ThreeJS. Intensity, hex and intensity. I thought there was more to it than that. So it's the colour and the intensity of that light. I'm sure it had a position and everything, but could be thinking of many other. There's a few other lights. X for white, and intensity, so it's not 1. You can go above 1. Sometimes you can't, sometimes you can. I don't remember off the top of my head as I use too many of these things, and they all vary in slightly different ways. So that's our light, and we want, what did I say in the variables? Sphere geometry, sphere material, sphere mesh. So one at a time. Geometry sphere, sphere. In Babylon, it's sphere geometry, I think. Sphere geometry, and that's the parameters. Did pick it up, I was probably doing a typo. Okay, so radius 10, segments is the number of divisions, subsections in the 3D mesh itself. The more you have, the more rounded the sphere will be. So I'll keep it low so you can see what it looks bad. Width segments and segments height, cross sections width-wise and height-wise, and don't bother with the rest. Sphere material is a new Phong mesh Phong material. I think this can just take a color, or it's color. Specular is shine. Take a value, so let's have a look at specular, and this is where you shouldn't be using the minified. You should be using the normal one. For debug purposes. So I've gone into ThreeJS's function itself now. Specular takes a color, so it's taken in that, and new 3 color, I think it was it RGB, okay. 255, 255, 255. Let's try that. Let's keep it out for now. Sphere mesh equals new 3 mesh. And we add geometry, and now that's much better. We got code hinting, IntelliSense, sphere material, and we add this to our scene. Let's test. Back to minified. So what we got going on here then? Delete and test. Now directional light. New. One word. So there we have a dark object. There we go. So as you can see, it's not round. Let's raise the position of this. Let's increase the size of it so we can see it better. Radius. Go back to non-minified. I'm hoping radius should have been 40, so when I change this, it would just automatically just move it up. Let's see what it actually turns out to be. Undefined. Well done. So there's a good example of a crazily low segment, low vertex sphere, if you can call it a sphere. Also, materials have a wireframe property, and it's great for debugging because you can see the wire. Typically, that's not a good wire material type to use. Mesh Phong, as it reflects light, takes light into account. Use mesh basic material, and you can see things much better. So if we increase our segments, let's go a bit crazy. As you can see, that is much rounder, but a lot more detail. Let's move our camera up a bit. Not so far away. And we want to look at 40 up, center of the sphere. Okay, let's put our Phong material back, turn off wireframe, and we have a nice smooth sphere. You got to watch frame rates. If you have too many of these going around and you've got a low-powered GPU or a very old computer, you're going to run into lag and frame rate issues quite early on. Let's check out the specular. There we go. So that's the power of the reflective light. And I think we have specular. You can, I thought there was specular intensity, but it must be based on the color. So it's 0 to 1, so yes, RGB 0 to 1 and 0.1. So great for a snooker ball. And if you want to change this to a cube, with IntelliSense, come on. So I think one is segments, width, depth, height, size. That is incorrect. That's it, box geometry. So they will default after that setting. Let's have a look at that. Tiny, 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 tiny. I just noticed I put cube geometry. I'm used to a way 3D, which has cube geometry. I don't like box. See what happens. Looks like they do the same thing. Okay. Must be a depreciated function, or maybe put in there purposely for people like me. So 10, you make rectangles with this and everything, so 30 by 30 by 10, you end up with something like that. You need to put the light in a better place, so let's play the light. So add another light. There we go. You see the sides a bit better. You can end up playing with lights for hours. So let's say we want to spin our cube around, which is not really a cube. Let's make it a cube. And I know it's called sphere, but let's just ignore that. And in the renderer, we can have an animate. We should animate stuff, or call an animate function, or animate queue. You can make a queue system if you're doing something serious. So that's your camera for when you've got inertia turned on. Otherwise it does nothing, inertia. It actually draws and recalls this function on request animation frame. So let's animate our cube, which is put into sphere mesh, and sphere dot rotate yon x plus equals 0.1. Three does love its tiny value, by the way. So let's make it a bit more sweeter. Simple animation in a basic ThreeJS scene. I don't recommend you trying to remember this. Use a template and just keep referring back to docs. There's no point in trying to commit this to memory. It changes, and it changes often. And Babylon.js is also a good alternative. Very, very similar. But you do get Babylon.js arc camera. The documentation sucks, and it's often offline and it doesn't respond like it's doing now. And the examples don't often work. Yeah, they need to purchase decent hosting for starters. Let's see if I can just find a quick example for you. Yes, we're not going to see that. So Babylon.js, same thing, looks slightly different. Same setup process almost. They do have their own little preloader which you can strip out. Well, you don't have to cut it out of their code, but you can just set up things the way you're doing it here and build your app the way you want to build it. Oh, and if you want to do camera animation, you can animate the controller. So you can controller dot angle. IntelliSense as a function. Yeah, I would strip out the controller and just animate the camera directly. So in effect, you're building your own controller. Yeah, you can do it via this. You just need to find the right function for the thing. Take it out and animate the camera, and then you won't need any of that or anything like that. But if you want mouse control, use the orbit controller or the trackball controller, which is, I'll show you the trackball controller while we're here. So that's our orbit controller. We're going to need another one from the GitHub source. Trackball controls. Now in app camera control. Now, this has inertia already set and it's much nicer than orbit controls. And this is new Three trackball controls. And it's the same as the other one. Camera renderer DOM-L. And we set a target for that as well, I think. Put this back to 0. And I don't think we need camera controller update. Or do we? Let's find out. Yeah. So as you can see, it moves a lot slower, and as you can see, we're losing the orientation. So let's fix the speed issues with this one. It's great for looking around single objects, but if you have a plane or a floor, you will tend not to use it because you can't get it flat again. It's just impossible unless you create a function and a button to press to animate the camera coordinates back to 0 and the rotation X, Y, and Z. Or if you're going through Eulers and angles, it takes fuss. So it's nice, but the other one is more useful, more practical. And that's your basic ThreeJS example. Thank you for watching.